Hello, it's Miss Butcher here, and this is video 6.2-8. We are going to be solving simple logarithmic and actually exponential equations. Alright, so I'm going to start with exponential equations. To solve an exponential equation, where the variable is in the exponent, but the bases cannot be made the same, we are going to rewrite the exponential equation as a logarithm, and then use our calculator to solve. Alright, because we've tried ones where we said 2 to the x equals 8 to the third. And then we said, well, 8 can be changed into 2 to the third, and then that's to the third. So 2 to the x equals 2 to the 3 times 3 is 9, therefore x has to be 9. And that's an easy way to do it when we can make like bases. But if I have a problem such as 5 to the x power equals 7, I can't make those have like bases. So what I'm going to do is change this from Ben, change it from base to the exponent equals number, change it to Benny. So we're going to rewrite it, which you guys know how to do, log base 5 of 7 equals x. Because it's log base 5 of 7 equals x. So now log base 5 of 7 is something you can punch into your calculator, and once you've written this part down, that's enough work for me. You can use the calculator and give me x equals 1.209, and I want 3 decimal places. Alright, let's try this one. 6 to the 3x power equals 5. We can't make 6 and 5 into like bases, so we're going to rewrite it as a logarithm. Log base 6 of 5 equals 3x. And then log base 6 of 5, that's a number we can get in the calculator. This is a single number right here. So we're going to take that single number and divide it by 3. So if you punch in log base 6 of 5 in your calculator, just hit enter and then hit divided by 3, enter, and you'll come up with x equals 0.299. Make sure that when you're punching it in that you don't do this. Log base 6 of 5 over 3. That's not going to work. So here's one, 2 to the x plus 3 equals 9. When you have an exponential equation and you want to rewrite it as a logarithm, before you can rewrite it as a logarithm, you must isolate your exponential part. So in this case, we have to move that 3 out of the way. We need to subtract it, and we have 2 to the x equals 6. Now we can rewrite it, log base 2 of 6 equals x. And log base 2 of 6 can be done in the calculator, so we know that x equals 2.585. We can do these with negative exponents. We have 8 to the negative x power equals 2. So our exponential part is all by itself. We can rewrite it log base 8 of 2 equals negative x. So basically whatever you get for log base 8 of 2, you're going to negate it or multiply it by negative 1, and then you'll have x. So you punch it into the calculator and you get negative 1/3, or 0.333 repeating. And one more of these examples, I wanted to give you one like this because we've got 3e to the x equals 11, and you guys know that you cannot multiply these two things together because e is being raised to the x power and 3 is not. So you have to isolate your exponential, and that means even if you've got coefficients, you've got to get rid of them. So we need to divide both sides by 3 and make this e to the x equals 11/3. Now that we have only our number to the power left, now we can rewrite it log base e of 11/3 equals x. And log base e is ln, and you have that button on your calculator, so just punch in ln of 11/3, and you should get a value of 1.299. Okay, now we're going to move on to logarithmic equations. To solve a logarithmic equation where the variable is what's being logged, all we need to do is rewrite that into exponential form, and then we can solve it. So here's an example. I have log base 3 of x equals 7. I want to stop and pause. I want to make note. Some of you are having issues with this. On the last test I noticed this. The base is a little number that's written lower, like a subscript. And then the x is written the same size as the word log. And the 7 is written the same size as the word log. So it's all the same size except for the little subscript. Please make sure that you're doing that when you're writing this down. Alright, so log base 3 of x equals 7. I can't punch log base 3 of x into the calculator, but I can rewrite this with my base being 3, raise it to the 7th power, equals x. And then 3 to the 7th I can do in the calculator. X equals 2,187. Alright, next up we're going to do log base 2 of x plus 9 equals 4. And it's very important that you pay attention to where your parentheses are, because this is not taking the logarithm of x plus 9. This is only the logarithm of x. So this is your single number right here. Log base 2 of x is a number. And then you add 9, and then it equals 4. So before we can rewrite this as an exponential, we have to get that 9 and move it to the other side. Subtract it. So we need log base 2 of x equals -5. Now, that means I am going to say 2 raised to the -5th power equals x, and x is 0.03125. You can do that in the calculator. As long as you get this work and this work written down, you can do the final computation in your calculator just fine. Okay, so this next problem looks just like the one we just did, except I put a pair of parentheses in here, and that implies that all of x plus 9 is being logged. So now we don't subtract 9 from the 4. The 9 and the 4 do not go together at all, because 9 is part of what's being logged and the 4 is not. So we're going to start with the 2, raise it to the 4th power, and then say equals the group, x plus 9. So now in order to solve for x, we need to take 2 to the 4th power and then subtract 9. And 2 to the 4th minus 9 is going to be, well, 2 to the 4th is 16. 16 minus 9 is 7. So it's a different answer than when we didn't have the parentheses. So those parentheses are very important. Okay, on this one, it's log base 7 of 3x, and there's not parentheses because when we do multiplication, we just assume that these two are together. So this should really look like this. Log base 7 of 3x equals 1. So we're going to take the base 7, raise it to the 1 power, and that should equal 3x. So if 7 to the 1 power equals 3x, 7 to the 1 is 7, and we have to divide both sides by 3, and we have x is 7/3. So a very similar problem. Now we have the natural log of 3x equals 5. And you have to remember, and if it helps you, write a little e down there. And then take your e as your base, raise it to the 5th power, equals 3x. So you can do e to the 5th in the calculator, and then you're going to divide it by 3. And e to the 5th divided by 3 is 49.471. 3 decimal places. Alright, and then the last type of logarithmic equations that we're going to do today is what we have if an equation has a logarithm on both sides of the equal sign. But if we have log on one side and log on the other side and nothing else, those logarithms can cancel out. And when you solve this way, then you're just going to cross out the logs and solve it like baby algebra. But you must plug your answer back in to check that it works, because there are some things we can't take the logarithm of. So you just always have to check these. Alright, our first example is log base 8 of x equals log base 8 of 17. They have to be the same logarithms, but we do have a log base 8 on one side and a log base 8 on the other side, so we can just cancel them out. And we can say x equals 17. And that's it. But you do need to check it. You need to plug it back in and say, does log base 8 of 17 equal log base 8 of 17? And you can punch that into your calculator and it works out just fine. Okay, this next example, we've got log base 45 of x plus 8 equals log base 45 of 2x minus 2. And I made it a gigantic base because it doesn't matter. This log matches this log, so we're going to cross them out. If these are the same and these things have to be equal, then x plus 8 will have to equal 2x minus 2 for them to equal each other, for the logarithms to equal each other. So then we just solve for x. If I added 2 to both sides and took away x from both sides, I'd get 10 equals x. And then make sure you plug it in and check. Of course, I didn't leave myself enough room here, but if we have log base 45 of 10 plus 8, that should equal log base 45 of 2 times 10 minus 2. And that's 18 and that's 18, so that checks out. Okay, our last one, log base 8 of 3x equals log base 8 of x minus 8. So you see that we have one log base 8 on both sides. We can cross them out and we can write 3x equals x minus 8. So if I took away x from both sides, I'd get 2x equals negative 8, divide by 2, x equals negative 4. So when I plug that back in, I have log base 8 of 3 times negative 4 equals log base 8 of negative 4 minus 8, which is log base 8 of negative 12 equals log base 8 of negative 12, which on the surface looks like, yeah, that's the same, so it's equal, but log base 8 of negative 12 doesn't exist. You can't take the log of a negative number, so you have to know that rule. Log of a negative number doesn't exist, right? That's why our graph has an asymptote at x equals 0 and it doesn't go anywhere to the left of it. So if your answer can't exist, then that can't be right, so our answer has to be no solution. And that's the end of today's lesson.